Excellent. Welcome. So this evening, we're going to be exploring the future and the art of human technology, the edges of our cutting-edge building process, so to speak, on this planet. And we're going to be exploring a lot of different ideas, and as we go through here, there may be parts of this talk and certain concepts I bring up, you might be all about it, and there might be other parts that you're like, I don't know what the heck he's talking about. But if you stick with me, I'll bring you through to the other side. Because where we're going is a really, 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 really exciting thing. Where we're going to end up after we go through some of the transitions and complete some of the technologies we're building right now winds us up in a place where we're going to be having some serious galactic fun. But before we go there, and before I get to all of that, I'm calling this talk Tech v2012 to play off of all my geek friends, but also because it's almost the year 2012. As we record this right now, we are in October, coming to the end of that, and that leaves us about 2 months before the year 2012, which is constantly streaming itself through the collective consciousness right now. It is the constant byline and word that is talking about thousands of years of prophecy and major changes on this planet all coming together to a close at once. And it's a really exciting time. It's a super exciting time to be alive. So the main question that I'd like to ask, I mean, we've been through a lot. We've had the development of the wheel, we've had fire, we've had, eventually industrial revolutions, we have computers, and in the 1950s, 1960s, 1970s, we were looking at this time right now, and there was some really, really fantastic stuff we saw. Back to the Future Part 2, levitating shoes, boards, cars. So the question I really have to ask you guys right now is, dude, where's my Starship, man? Right? Shouldn't we be right there on the Enterprise now? Shouldn't we have this opportunity to be broadcasting galactically across civilizations? Everybody thought that's where we were going. You look at the curve, you look at how fast everything else accelerated, and you're left with this big question. Come on. Where's it at? Right? Well, we're going to talk a little bit about that, and we're going to talk about why we don't have starships yet. But first, let's look at the main culprit. The combustion engine. The combustion engine has been our primary means of energy and transportation for 400 years. Did you know that? Do you know there was basically engine systems developed 400 years ago? And what they were at that time was it was a heat-based pumping system to pump water. And it recirculated water, it helped move water through a system through burning stuff, right? Well, we did a pretty good job evolving that. If you look on Wikipedia for the combustion engine, you see, every 100 years there's 20, 30 improvements, boom, 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 boom. So many improvements to this system all the way up to 1954. And then they just stopped. In 1954, we developed the Wankel engine, and that is still the engine running BMWs today. If you look at other technology we're using, right? You look at computers, for example, biological knowledge, astronomy, telescopes, rockets. You look at all the other sciences, which we're about to do, and you tell me, why are we still using the same engine model as in 1954 that's just polished up a little nicer, has more electronic parts in it? What happened? Right? I got another question for you. This is another big problem. This is another big reason why we don't have starships. What's that about? Well, gold is a serious issue. Gold is one of the major reasons we have poverty, death, and war, and it's been the base of our value system for over 2,500 years. We've based our system of value on a metal that's a certain color. Why? What's the reason behind that? These are important questions to ask. And another major issue we have on this planet, land, right? Real estate battles, Holy Land battles, battles over Jerusalem, battles over indigenous lands, and people being moved off of their land to either clear-cut it or to build reservations. Biological preserves all over the world, constantly being attacked for oil, for other resources to power those combustion engines, right? And we've been fighting over it. We've been fighting over land and space for a very, very, very long time. Well, it's time to move beyond that. And that's where we're going to go next. And it is really, really a good time to be moving beyond that, because we as a species have made some of the most incredible technological advances in the past 10 years that anybody's ever imagined. And where we're at right now is on the cutting edge of something entirely different, where this is not an issue anymore, where gold is not an issue anymore, where this is not the main source of energy and transportation, and we'll know exactly where my starship is, right? So, it's time for change. 2012. Also a pretty good film. Some of my friends are in that film. Sting is in that film. I recommend it. Here's what we're up to. Biology, right? In biology, we've got some serious DNA and sensory revolutions going on. Dr. Sonia Contera, 98% of DNA is a mystery. She established that basically our ideas about the genetic code are extremely minimal in our understanding. And yet at the same time, we've apparently coded the entire human genome, mapped the whole thing, we can map your ancestry, we can map all of this stuff, but 98% of it is a mystery because only 2% of your DNA is what they find code proteins through your ancestry. And the other 98% is unknown, what it does. Well, there are some really interesting theories about that DNA, including that it changes every moment. In other words, as your cells are replicating hundreds or thousands a second, your DNA is also changing. And some of that DNA changing becomes hard-coded. And that's part of how we evolve. And we can evolve very quickly. Genetic life extension. Walter Longo, USC yeast cells. He was able to preserve the life of yeast cells from 1 to 10 weeks. Basically just through turning off a gene, right? Sonar sight technology. They've learned how to mimic bats and mimic other animals like dolphins that use sonar to see and send that through information to the brain so someone can actually see using sonar sound waves. Dope. Artificial retina. We now have the ability to implant a retina that can actually take in light from inside the eye, just like another retina, and process into visual signals. Now, right now, it looks like a bad YouTube video with lots of pixelization, but you can tell the forms are there. You could walk around. They could safely cross the street and see cars coming, or it will be able to very, very, very soon. So that's biology. We've made lots of leaps. Nanotechnology. We have DNA-based construction. We take DNA and we're able to build stable structures and shapes out of it on a molecular level, right? Nanorobot clouds, building tons and tons of tiny machines that can electrostatically charge and bounce off of each other, surround an object, and change that object's shape and form. I met a gentleman 5 years ago working on that, and at that time, they wanted to send swarms of nanorobots into a room, so you have a one-room apartment that in the morning is your bedroom, and in the afternoon, it's your kitchen, or it's your living room, or whatever you want. And it changes throughout the day just from a swarm of little robots going in and rearranging the molecules. Nanocars, made from a single molecule that makes a car, a small itty-bitty molecular car that's moving. That's already been done. That's working. Rice University built that. Nanoceramics, my friend John Orova, who recently passed away, built a nanotechnology-based building material that can take the heat of the sun and turn it into pressure inside the walls to move turbines, generate energy, whatever you want. Nanomedicine, they're getting in there and actually working on the cell walls of things. We're doing some really amazing things at very, very small scales. Communication, how much do I need to say there? Right now, I can have nearly instantaneous voice conversations with anybody anywhere. Video conversations. I'm talking to people logging on right now, online, all over the world. Image and file transfer. I can take a picture of you, I can send it to my grandma right now. GPS locating. You can find out where I am, I can find out where you are, anywhere in the world. Because satellites can track our phones and we can walk up to each other. I can find friends at a nearby cafe. Instant global distribution of media and materials. I could record this right now, which I am, and afterwards, basically, compress it down to a podcast, upload it to iTunes, and people can buy it, watch it, share it anywhere in the world instantaneously, right? Just from this one thing. Portals, right? Connecting two spaces with projectors and cameras. Weather reading. I can tell exactly what the weather is going to be, or pretty close, wherever I'm going next week or tomorrow. You know, I can rent a house before I get there, that I borrow a house from someone I don't even know, you know, when I go to New York, and I just do that online. Communication is incredible right now. Astronomy. Planets are everywhere. Marcus Jansen's team in Toronto found a planet that has an atmosphere, and it's 130 light years away. It's a planet around a star with a full atmosphere. William Baroki and NASA says there's countless planets in our galaxy alone. At this point, they think it's extremely, extremely high percentage. But I'm going to talk about that later, of the planets that actually could habit life that is around other stars, not only stars nearby, but all over this galaxy, and in fact, every galaxy. Tornadoes in space, we're studying fluid dynamics in magnetism through giant gas clouds in space, and seeing that there is a lot of similarity in the patterns that happen in interstellar space, where there's a vacuum, and the patterns that are happening on Earth, suggesting there's a deeper geometric process that causes those tornadoes in space and tornadoes in Earth that's not just about pressure. Okay? Something else may be going on. And we have 3D views of the sun now. We have 2 satellites that can give us full 3-dimensional views of the sun. In physics, we have emerging unified field theories popping up all over the place. My favorite, the Schwarzschild proton theory by Nassim Haramein. He believes that all protons, in fact all matter, contain black holes at the center. In fact, every point in space-time does. And that if you have a proton that has a black hole at its center, that black hole is actually connected to protons all over the universe through a network of wormholes. In other words, there's instantaneous information transfer. It's as if you take parts of space-time and you pinch parts of space-time in different locations together into a point. So that point changes, and those points change at the same time. Explaining supersymmetry and things like that, other big issues in physics. He runs up against a lot of opposition, and that a lot of that opposition is valid, but it's also a totally revolutionary model. And we're only just beginning to understand what it actually could mean. And he's been able to pull out some really, really incredible equations from the model, rewriting Einstein's equations so that college kids can do them, and basically developing them to a point where you can actually model the entire universe from a single proton. So it's changing a lot of ideas about holographic theory and the connectedness of the universe. DNA teleportation, Luc Montagnier. He took a glass of water, he took DNA on the other side, and was able to recover patterns of the DNA code from the water that the DNA was not in. They were just in a contained electrical environment, so the Earth and no outside forces could get in there. They set the vibration at the same hertz as the Earth, and the DNA imprinted itself into the water, and the information code of the DNA was able to be pulled out of that water. And all they were doing was sitting next to each other. Quantum teleportation. At Hefei National Lab, they've been able to get up to 89% of all the information in a quantum coherent structure over 10 miles. Right? Teleportation, it's coming. And the fun stuff, invisibility cloaks, Shuangzhang, natural calcite crystals, using a patterning of calcite crystals to bend light around an object. Yes. Phonons, sound lasers, lasers of sound to project sound specifically to an ear or to a head or to a space across long distances, right? That's amazing stuff. Star Wars holography, real-time dynamic holograms, University of Arizona. Mind meet computer. Well, my friends down at Singularity University at NASA Ames, the space team, just won for the space team project, and what they were able to do in 3 weeks was take all the mind-computer interface software and systems out there, they hacked them, and they rebuilt them so that you could then wear this thing on your head, and you could, in a virtual space, completely control all the movements of an avatar in 3D. In other words, the avatar inside the computer, the character that's rendered in 3D, when you raise your hand with your mind, the character raises its hand. When you walk with your mind, as you're sitting in the chair, and you're thinking, I'm walking, the avatar walks. You think jump, the avatar jumps. You think fly, the avatar flies. Now, this is huge, and the reason they won is because with that kind of technology, you could totally manage and control robots building facilities on other planets, because you'd actually be there thinking, and the robot would be doing what you were thinking of doing. So this is like the movie Avatar, like being in another body if you wanted. It's also virtual projection. Has a lot of ramifications. I'm sure you guys can think of some of them. My favorite is using that to pilot a starship. So, yeah, we've made a lot of big changes, right? We've moved forward in huge ways with all of this technology. Well, yeah, but we're still running gas in our cars, right? We're still using the combustion engine. What about changing the energy system up? We need to do that. So there's water technologies that people are working on. Accessing the energy in water, because man, isn't water cool stuff? So Francis Cornish made a water engine in 1982, disappeared in 1988. 1981, that water engine was tested by BMW, and it said it was working great, everything was checking out fine, it was awesome, they were having a little bit of oxide buildup. Does he have any answers or solutions to that? Shortly later, gone, the patent's still there. And at this point, I believe it's expired, and anybody can take that and start working on his work. Why aren't we seeing it yet? Where'd it go? Water Energy Systems by GenePax in 2008. They have a mini car. It drives around. It runs on water. Website closed down, gone, 2009. HHO electrolyzers. Highly debated efficiency improvers. People have seen these YouTube videos. Use HHO, they put water in. It's turning it into hydrogen, oxygen. It can be burned at really high rates. The guy gets in, he's driving a car, he's like, I'm running this on HHO. Well, it's gotten tons of flack. The Automobile Association denies that it works, says, we're not sure, this is a bad idea, you shouldn't do this for your car. But lots of people are building them and trying to make them work. We're definitely in a direction with that, and it's definitely working on some scales. How efficient it actually is, we're not sure yet, because it's not populating the mainstream. Active researchers, I know, are currently working on this technology. Can't tell you who they are because they've encountered a great deal of resistance. They've had partners that have had resistance towards putting this technology out there and building it. They've had funders withdraw at the last minute due to very, very odd reasons. And so this is something that's on the cutting edge. There's something about to pop, but there are definitely some issues that certain groups have about getting this out there. And I think it has to do with that engine. I think it has to do with oil. I think it has to do with a variety of things. But right now, we'll just benchmark that, and you can explore that on your own. Solar technology, capturing and focusing sunlight. Well, Nano Solar makes printable solar cells now, right? They're going to be majorly released very soon, but you can basically print these things onto any shape, fabric, objects, glass, whatever you want, and then that thing can absorb energy from the sun. So you could have printed solar wallpaper, you know, all over the side of something, or on your car, or wherever you want, and it can be tapping that energy, right? And they're refining that model to get that out. Concentrated sun things are another really, really big thing where they take giant mirrored disks and they're using the heat of the sun onto small focal points, or in some cases, thousands of mirrors reflecting onto a single tower and superheating it to the point where it's generating massive amounts of power, including up to 5 megawatts at the Next Era facility, which I believe is in Arizona. Cold fusion, and this has been a very mythological energy source, but this is where we need to go. We need to stretch boundaries. We need to stop thinking about things the same way, which is mostly through combustion. How do we get something really hot and blow it up? We need to think about how energy functions at lower temperatures. Well, there's actually been some movement in that recently. Fleischmann and Pons back in the day, over the 80s, there was huge controversy over their release, which they said that they took hydrogen and water through a palladium matrix and it released helium and heat. And the amount of heat it released, they said there was no way that that amount of heat could be released without some kind of nuclear process happening, right? Didn't make sense. Well, for a long time there was debates, failures of experiments, disappearances of people, and then in 2002 the Navy comes out and they start talking about thermal and nuclear aspects of a palladium D2O system, which is similar to an H2O system. Yoshiaki Arata in 2008 demonstrated a working experiment at Osaka University. Not sure what's happened with that. NASA Langley in 2011, quote, interesting and promising new tech that will advance fairly rapidly. Now they were talking about low energy nuclear reaction. That's cold fusion. That's the same thing. And I failed to put the gentleman's name up there who said that quote, but I'll make sure to add that later. But apparently it's still a very, very potentially highly rapidly growing area where we could get energy from. I have a friend in Hawaii. It's a gentleman living on Kauai, and he's been working on amazing cold fusion. He's a much older gentleman, and he's been working on basically stabilizing the reaction based on the size of the focal tube that's being used. And he's also using laser light matrices to basically trigger certain reaction speeds inside of that. So there are people actively working in this field as well, and I think it's poised for some breakthroughs. Now, here's the big key word when it comes to energy systems: 0 point, right? Don't we all just want the 0 point energy system we can stick in our back pockets or in our phone and it just runs forever, right? Well, 0 point energy is something that's already extremely abundant. In any magnetic field between the positive pole and the negative pole, energy pops in and out of space-time. We've seen that for a long, long, long time. And certain experimenters over time have made some practical improvements on how you could actually tap that energy, right? Well, of the variety of approaches that there are, there's the ZP magnetics approach, which is using a magnet and basically either rotating, spinning the magnet, holding it solid, and trying to tap the energy coming out of it. There's implosion systems, which are based on taking energy, focusing it down, pulling it out of a, basically like a wormhole in the center of a vortex, right? A torus is a donut. It has vortexes coming in the top and the bottom, similar to this Victor Schauberger diagram we have over here. He was talking about actually using that same type of toroidal generation system, which actually is also causing implosion, to generate lift in a craft or crystallize water or release energy and generate lift, similar to a spacecraft. And we also have polar cone resonators, which is an idea that involves resonating a series of metallic cones that are like bells that have an electromagnetic repulsion off of each other and begin to spin at high speeds. And because they're cones, you're focusing high-frequency electromagnetics and low-frequency electromagnetics, and you're creating an envelope between the high and the low, right along the middle, where that zero-point energy can be accessed and begin to be routed into things. And that's also some close friends who are working on that subject. So great, new energy systems, awesome, right? Change things in a big way. Localize energy, release a lot of conflict, right? But what about the economic system, right? What about the economic system? Don't we battle a lot over economics on this planet? Don't we fight a lot over resources? Not just energy, but I'm talking about all kinds of resources. We fight all the time over, I have this, you have that, I want your diamonds. I want the gold in your country. I want the silver. I want the resources. I want the oil. I want the whatever. I want, me, mine, now. Right? We have issues. And that's okay. Because we can get beyond those issues if we start to understand resources on a deeper level. And what I'm talking about there is making things. Making things out of the fabric of space-time, building things from scratch. Right now, we have 3D printers. If you can render it on a computer, we can print it in 3 dimensions. This is an object printed layer by layer using a 3D printing system, right? And we're beginning to do that with a lot of different kinds of materials. But let's get beyond 3D printers here, people. Let's talk replicators. Let's talk building stuff using the fabric of space-time, right? Let's talk, I walk over, I plug a little bit of information into my Star Trek device in the wall, and it gives me a cappuccino from anywhere in the world. It can give me a green drink from the Ionian star system. It can give me a full platter of chicken right there, boom, just like that, because it's just assembling the molecules, just like Gene Roddenberry envisioned, right? Sounds like a really, really cool thing. Well, level 1, let's make them happen. The Excimer laser LIGA, lithography, galvano, and Abformung systems. What those are about, we're basically using laser light to shape molecules and molecular structures for basically galvanization and building of objects, right? These guys were working, Dick Basting, Jared Marofsky, back in the day. They have a book out. It's pretty awesome. Well, some of what that became was molecular beam epitaxy. Sharp Labs at Oxford, this is a photo of one of their machines. They take lasers that carry molecular structures on top of the lasers, right? And they beam on single molecules, and they can build any object out of a huge variety of molecular resources. What they mainly use them for, because it's sharp, and they make TVs and stuff, is they build tiny, tiny circuit boards and systems, and they're revolutionizing that because they're building them one molecule at a time, one atom at a time in some cases. And they're actually able to build super complex dynamic objects, building them by one atom at a time using laser light. Wow, now that was an earthquake. We are shaking things up here with that one. Whoa! Nanotechnology. Oh, we are still shaking. Is everybody good? Okay. Projector is Still quivering. Nano-robot construction. Boris Fritz, CPAC. What Boris was working on, this is the gentleman I spoke about with the nano-robot cloud system. I met him years and years ago at CPAC, working for Northrop Grumman, and basically he was building systems to fully construct three-dimensional objects and shapes in space out of any materials using tons of nanorobots working in sync together. Well, I think all of these things are great, and they're great for like a starter, right? But here's how we actually can do it. This is how we get to the next level. We use cymatics, the science of understanding how sound can naturally generate geometric structures. And if we have sound lasers, we can hit extremely, extremely small spaces and areas with very, very precise geometries of sound. And different sound geometries will resonate differently with different molecules, create a standing wave shape at a very small size. And it can be extremely complex shapes. And then you use an MBA geometric array, a series of lasers in the geometry, and you shoot the molecules once they're holding that cymatic structure, and you send some molecules into it when you need to, and bam, you start to get an object. And then you use molecular sculpting, which Timothy Zier is working on, to actually help sculpt the molecular structure using the sound and the light to move certain things into position. And then finally, the next level is actually when we recognize not only how to do it with laser light at molecular levels, but when we learn how to use the sound and the laser light combinations to affect the Planck scale. When we start to affect the fabric of space-time itself, the smallest possible scales that we know about, where quantum foam actually happens, and we're dealing with the quantum dynamics of the fabric itself, and we're just shaping that with photon light and sound vibrational structures holding waves inside of that, that's when we get integrative replication. And from the Planck scale, you can make any molecule, any atom, out of any other atom. So then, at that point, I get to do some really cool stuff. But some questions arise from this, right? So, for example, if I can make tea from a block of wood, right, how do I record the tea? How do I record the object that I'm trying to copy, right? That's really important, and that takes a lot of information to copy a cup of coffee. But we're getting there with our computing systems now. We're getting to the point where we can store massive amounts of information, entire quantum systems of an object. But we need a way to record it. And then what happens if we record food? Well, if we're doing it on a geometry level, we might not, if we're doing it on a molecular level, we might not get quite as precise in what we're making and recording as we would if we're doing it on a Planck scale level. The difference is that at the Planck scale, you don't miss a single drop of the information. In other words, the object's gravity field, electromagnetism, its entire energetic structure, the heat signatures, all the resonant dynamics, and if you're into metaphysics, the energetics of the object itself are copied at that level. But when you're dealing with molecules, just molecules, you're probably not going to get the same tomato. Not exactly. You're going to get a copy, and that copy is not going to be quite as good, right? So we need to get to the Planck scale working on that, right? And once we do that, how do we then make it really big so that we can actually fly a ship over a massive pile of trash, like a landfill, and basically hit it with sweeps of the replicator and turn it back into soil and instantly compost it and instantly change it, right? Get it back to what we really want it to be. And this is how we get replicators. This is how we make it happen. And when that happens, it changes a lot. The moment we have replication working, suddenly you have a serious, serious problem. Our entire value system goes out the window. But that's actually a great thing, isn't it? Because our entire value system is based on paper, an idea of numbers in a computer, and it's supposed to be based on gold, right? Which we're fighting over all the time, and minerals, and the limited resources that we have. But if you can copy anything, gold doesn't have value anymore. You can make as much of it as you want. Diamonds don't have value. You can make tons of them. The cup of coffee, the resources, all of that stuff, the transportation, the gas used to move something somewhere else. If you can copy anything, send it through information over the internet to a new location and print it out, now the value is no longer material. It becomes social. It becomes artistic, right? So it's not about the fact that I can have a cup of coffee anymore. Anybody can have a cup of coffee. It's about the barista that made that cup of coffee. It's about the person who grew the beans, roasted them, milked the goat, gathered the sugar from the sugar cane, right? Processed that down and used just that sugar or just that honey and just that goat milk and just those beans and ground them just right and mixed it just right and steamed that milk just right and poured it just right so that it gives you a nice little pattern on the surface of the cup. That is what is valuable. It's the art of the person who creates something to share. So will people still grow tomatoes? Absolutely. They're going to try to grow the best possible tomatoes they can with their totally organic gardens in their backyards, because when they get that tomato that's like so perfect, that heirloom huge tomato, they're going to take it over to their replicator recorder and record it in, and that same tomato can be made by anyone, anywhere in the galaxy, hopefully, right? That'd be pretty cool. So the value becomes what you have to give. Right? So where do we go from here? Right? New energy systems, replication, building new stuff, like from nothing, changing the whole economic system, ending the energy crisis. Well, what's next? New worlds and new civilizations to boldly go where no man or woman has gone before. That's what's next. So what about these new worlds? Great, right? We like new worlds. Well, check it out. William Barucki, countless planets in our galaxy alone. Remember? Well, it turns out that we think at this point that around 1/3 of sun-like stars should have at least one habitable planet. 1/3 of sun-like stars. Okay. There are 100, maybe 200 billion stars in the Milky Way galaxy. Out of 200 billion stars, can you think of how many habitable planets that is? Well, let's say it's 100 million, and then you only have 33 billion habitable planets, right? 33 billion. Now, if you take that and say, and how many of those actually ended up with life? And let's say 0.0001% of those had habitable life. That is still a lot of planets with life, right? What do we say, 33 billion? So that would be going down 000. So that's somewhere in the range of like, let's even just say 3 million planets with life, okay? Or even just say 300,000 planets with life. And you take that, you take 0.001% of that, and you end up that possibly that have life, that have potentially life that has evolved to be conscious, like you and I, whatever, as if all life maybe isn't conscious, but maybe that's similar to us in some ways. And let's say 0.0001% of that is life that is conscious. Well, then you still end up with 300 conscious civilizations across the galaxy. And that's going as low as possible in those numbers that we could possibly have. And actually, we think it's probably a lot higher than that. Because guess what? Out of the random stars that we chose, out of the 100 and something planets that we've found outside of our solar system so far, we've already found one that we think has a 100% chance of life. That's not 99%. That's a 100% chance of life based on what we think that planet has, atmospherically, position around the sun, its size, the star's size. That's a pretty high percentage. Thank you, Dr. Elizabeth Cunningham. Sounds great. But how do we get there? Dude, where is my starship, right? Well, we can go with conventional propulsion, right? We got the explosive propellant-based standard rocket engine that just, it gets you all the way there, right? Well, that takes a while. We have some really advanced new ways to explode stuff to propel you through space, like ion propulsion systems using accelerated xenon thrust through electrostatic charge, which basically blows up the air and pushes you along, right? We have charged plasma systems, krypton Hall effect thrusters that basically blow up the air and get you going faster. And we have nuclear propulsion, where we literally explode a nuclear bomb behind you and push you through space with that explosion, right? And even with the best one, pulse thermal ramjets, whatever you got, travel to the nearest star, 19,000 years. Well, that doesn't sound like very fun. I don't want to get on that rocket and wait for 19,000 years, longer than the history of human civilization, to get to a star that's the closest one nearby that may or may not have anything, right? We got to think around this issue, right? To do that, we've got to stop pushing pencils through the fabric. That's what we're doing. When we accelerate something, acceleration creates gravity. All explosive thrust systems are based on accelerating something. You explode something, and it pushes something faster. Right? It's the wave, it's the shock, it's accelerating something from stop to go. And if you swing your arm fast enough, it starts to hurt your fingers because you're accelerating blood flow down to your hand, right? You're creating gravity, right? And the more gravity you create, the more you push against the fabric of space-time, the more you warp the fabric of space-time. In other words, you warp your local time frame connected to somebody else. So the more you push against it, the more energy it takes. You go faster and faster and faster, and it takes more and more and more energy to the point where it takes infinite energy to accelerate any faster, and that's just before you get to the speed of light. So you'd have to have infinite energy resources. You'd need the entire universe blowing up behind you to be able to reach the speed of light if you're pushing your way through the fabric, right? And it literally is like that. It's like stretching the fabric around you, right? And it stretches your time frames and everything else. So if you push your way through the fabric to Alpha Centauri, and even if you get enough energy to go 99% of the speed of light, and for you get to Proxima Centauri, sorry. You get to Proxima Centauri, and to you, it takes 5 minutes, But back on Earth, 19,000 years have passed. That's a problem. When you warp space-time that big, it is a serious problem because you get pretty disconnected from the state of affairs back in the normal time frame. So we got to get out of the fabric. We have to stop pushing our way through it. So how do we stop the curvature that happens through acceleration? Well, that's what we call anti-gravity, right? It's a nice U.S. Air Force, U.S. Army craft, one of their first anti-gravity crafts that they released out there back in the day. Well, we know it uses a giant turbine engine in the middle, right? But there are some suggestions through groups like the Disclosure Project that other technologies were being developed in the 50s and 60s as well that are a little bit more advanced. And we might talk about a few of those. But most of them, including anti-gravity, the main problem people see with anti-gravity is that the only way you can undo the curvature of space-time or undo gravity is to have negative mass, right? And they think that to have negative mass, you have to have negative matter, like the red matter in the Star Trek movie. It's got to actually have an effect of pushing away the fabric of space-time instead of gravitationally pulling it in. Anti-gravitational effect. Well, this is a kind of ridiculous idea. In Wikipedia, it says, under general relativity, anti-gravity is impossible except under contrived circumstances. Well, contrived circumstances still leaves it pretty open, doesn't it? Because pretty much everything we do in space-time is contrived. We create things, we move things, we change things. That's kind of what we're here to do, right? So negative mass, theorized by a few people, and the Tau Zero Foundation went through a whole process creating some new breakthrough propulsion physics programs. They started at NASA in 2002, and they suggested some really, really cool ways to get around the idea of negative mass by creating negative mass through diametric and disjunction drives, which use positive and negative forces, and ideally they would have a negative mass force and a positive mass force to warp space-time around the object and cause it to flow through space-time super fast. Cool idea, still not totally there. Warp drive, also known as the Alcubierre drive, contracts the space-time in front of the object, so it literally pulls the star that you're traveling to closer to you by taking space-time and just kind of bundling it up in a smaller space, right? And it expands the space-time fabric behind you. Well, great idea, except for that it also requires you to have something that can pinch the fabric of space-time outside of your craft and expand the fabric of space-time behind your craft. And to do that, you need some pretty exotic materials, which we don't have any idea how to make or create or access. You know, the closest we have is anti-quarks and anti-leptons and anti-hydrogen, but creating a stable set of those things at a scale that can create these effects might be a little bit far away. But don't lose hope. There are some other options. Field resonance propulsion. Alan Holt, NASA, 1979, suggested that we could create gravitational waves by pulsing electromagnetic fields in resonance with the fabric of space-time. In other words, we take the fabric, it's got gravity, it's bending and curving, and if you hit that gravity and you hit the shape of space-time just right with electromagnetism that's on the same level, then you could affect the gravity around an object. In other words, you connect the electromagnetism to the gravity, and when you change the electromagnetism, it changes the gravity. Now, this is based on a couple ideas, and one of those ideas is actually that, you know, there's a higher dimension to space and time, and that the effects that we see in space-time, including the shape of electromagnetism, the shape of gravity, that those things are going on at a higher level. We'll talk more about that in a minute. So, field resonance propulsion, gravitational waves basically created by acceleration warping the space-time fabric at the speed of light, right? So objects in space-time make waves of gravity around them, right? This is what Einstein thought. And he thought that basically those waves propagate through the fabric. In other words, they move, when an object moves, its ripples of gravity move at the speed of light. Well, that's interesting. If the fabric of space-time moves at the speed of light, maybe light has some sort of natural resonance with the fabric itself. Wouldn't that make sense? Interesting. So basically, what they found, and this is the work of the Philadelphia experiment and other similar experiments, what they proposed that through magnetic field line merging, super high electromagnetic fields, right? They're studying the sun. They found that 2,000 to 3,000 Gauss magnetic fields in the sun basically would create gravitational waves. Huge magnetic ripples in the sun could create a ripple in the gravitational field because the size of these magnetic field changes cause up to 10% of the total output of energy of the sun to be released in 1 second. Now, you think about the size of the sun. 10% of the sun, its whole energy released through a solar flare in 1 second, that takes more than electromagnetism to happen. That takes some much stronger than just magnetic fields, right? And so what the proposal was that Alan suggested, maybe it's causing gravitational waves. Maybe those huge magnetic shifts are rippling the gravity around the sun, which is causing huge releases in the energy field of the sun to happen through those solar flares. So that's how he found that this could be possible. So the idea is that you learn about the space-time harmonics of a location. You learn about basically its natural state of electromagnetism and gravity. You know, what's the gravity, what's the light around a star, what kind of light's coming into that place, what's the shape and the color and the geometry of the gravity, in other words, the space-time fabric, and the light moving through that space-time fabric in another location. And then you take an envelope around your object and you basically resonate the light, the electromagnetic field around your object to match that field in the other location. And when the fields match, the fabric of space-time would force the object to be in that new location because it's no longer in harmonic resonance with its surrounding gravity and space-time. So it would force it to move. Does that make sense to you guys? So in other words, you have red light over there by that star, right? And I'm over here in blue light area, right? And everything in this area has the blue light moving through it, including my spacecraft, right? But if I use the right resonance and shape around my craft to change the resonance around my craft to red, space-time thinks I'm in the red space. And so the object actually shows up in the red space. And this is the same kind of effect that we see through superpositioning of particles, that small particles move based on where you think they are. Quantum effects probability changes the location of an object in a quantum field based on what you think about it, right? So this is actually a way to technologically communicate to the fabric of space-time where you're actually at. You're telling the fabric of space-time, I think I'm here, and the fabric of space-time says, okay. All right? Really, really, really interesting idea. Well, we tried to measure gravitational waves, but the funding was pulled from the project. Bummer. If we could measure gravitational waves, we might be a lot closer to getting a resonance with them. Circulating light beams. This is another really cool method, and it builds on field resonance propulsion. It's the idea that you can basically create a resonance not just between magnetism and gravity, but just light, right? Just light. Now, electromagnetism is light, right? But there was a really interesting guy. His name's Ronald Mallet, and he built all of these theories around creating a time machine. He wanted to create a closed circuit, in other words, a closed time-like curve between himself in the now and himself in the past, or between his position in space-time now and that same position in space-time somewhere in the past. To do this, he theoretically said you could use unidirectional ring lasers and get frame dragging effects, right? And frame dragging is basically the idea that the fabric of space-time will actually like move with the laser. It will actually drag itself, back following the pattern of the laser. And as soon as you're doing that, you're affecting gravity. You're affecting the fabric of space-time. And then to get a closed time-like curve, you have to actually bend the fabric of space-time so much that it makes a singularity, a black hole, a wormhole, and then what happens is from the singularity that's created by the ring, when you move through the center of the ring, you're moving through time, and you can move back in time. Well, obviously, a lot of physicists had some problems with this. They're like, wait a second, you guys, you want to make a singularity with your unidirectional ring lasers that we have no idea how that could even work because we don't get your theory in the first place. But second of all, you have to have a singularity. You have to have a black hole. You know how much energy it would take to make a black hole? It would have to take a heck of a lot of energy. Black holes are big, and they swallow stars, and they swallow planets, and all kinds of stuff, right? Well, yeah, and also, space-time is finite, right? Space-time fabric is a finite structure. So you can't create a closed time curve, because you can't ever go to a place that's already been in the fabric. It is what it is right now, and that's how it is. You can't go to the past of it. That's impossible. You can move through it, but then you're somewhere else, right? Well, with that idea, I would say maybe they were getting close to something interesting. However, there are some interesting solutions to these problems, and they've been posed by Nassim Haramein, for example, with his Schwarzschild proton paper. And interestingly enough, in his paper, he says every point in space-time has a black hole. Every proton has a singularity already. And if matter is already, all the mass in the universe, all these things everywhere, already have singularities inside of them, then the job that Ronald Mallet was trying to do is already half done. That would mean there's already wormholes set up everywhere, right? He's already got access to it. And John Gowan suggested gravity and symmetry. His idea is that gravity has a symmetrical process. In other words, space-time is symmetrical with electromagnetism, light, and everything else. And if all of those things are in symmetry, and not only in symmetry, but as Haramein would say, infinite, it solves the problem of the finite space-time, and it also solves the problem of the light being able to create the frame dragging, and it starts to suggest that actually that might work. But moving back in time, we still don't know. But maybe moving through space-time, maybe yes. In fact, why create a closed time circuit? Why make a loop that you're stuck in like this? Why not actually just use that hyperspace thing to move through the present? Instead of trying to move from the future back to the present or from the present to the past, why not use it to move from the present to the present instantaneously? That might solve some problems, right? Because that's all we want to do with a spaceship. So, electromagnetism and gravity. Is there a resonance? Do the physicists say ding, ding, ding on that one? Well, in general relativity and E equals mc squared, gravity is not a force, but a result of the geometry of space-time, right? So gravity isn't a force at all. Space-time curves, and that is gravity, the curvature of space-time. There are some really interesting ways to look at that geometrically based on Buckminster-Fuller's work, some other talks I do, involving taking equilateral lattices of space-time and what it looks like to have them curve and fold and how that can happen. Because when we start to understand the geometry of how gravity happens, then we can start to address how do we change that geometry, right? Second, gravity propagates at the speed of light. Sounds good to me. Gravity moves at the speed of light. In other words, the geometry of space-time changes at the speed of light. Probably a connection to light there. Well, and you also have E equals mc squared. And E equals mc squared means that not only can mass create gravity, but energy can create gravity. So just as mass around an object bends light, light can also bend space-time and pull mass. And you can find that in any physics book anywhere on the internet. It would just be that the light would have to have a heck of a lot of energy, way more energy than we know how to make. And we also don't know how to make so much mass that we can curve space-time either. But there might be a key to this if we start to understand singularities. If we learn how to create black holes or use black holes that already exist, we might have the power to bend gravity like we want to, right? With light or with mass. So it's interesting. We also notice that patterns affect both light, pressure, and gravity, right? Patterns, like the logarithmic spiral, affect gravitation at galactic scales. The gravity arrangement of that entire galaxy is set up like that because there's a pattern that's affecting the whole pressure of all the forces in the entire galaxy together, right? And when we think of pressure, we're thinking about like weather, right? Molecules all butted up together really close, and it's pushing itself, right? Well, do you know how much distance there is between the gases and the stars in the galaxy? There is a heck of a lot of distance between our star and the next star. And most of that space, we believe, is a vacuum. It's empty. So the pressure between the two stars can't be just gases pushing up against each other, right? There's got to be some kind of effect in the gravity itself that's causing that pattern to happen at a galactic scale, because that same exact pattern is affecting the electromagnetism that makes this shell grow like this. And that same pattern affects the fluid dynamics in weather that happens on Earth, right? Hurricanes, tornadoes, right? And if the pattern can affect gravity and pressure and electromagnetism, then they all have to be connected in some way that's higher up or bigger or higher dimensional than just the forces that we see here in the fabric of space-time. Or they're connected on the Planck scale. And the geometry of the fabric of space-time itself reveals how light moves through it, and that light can affect that fabric, right? And if light can affect the fabric of space-time, we have good news ahead of us. It's going to be a lot easier to build a spaceship. Diamagnetism. Large superconducting magnets have negated Earth gravity in laboratory studies. We have made a frog float above a table just using really strong diamagnetism. That's pretty interesting. Well, we negated the force of gravity using magnetism, right? That's one step, but we got to do something way cooler than that. We got to access these higher dimensions. We have to start to understand the geometry of space. Well, there's theories that have talked about this. String theory, M theory, unified field theories. String theory and M theory base the whole universe on many, many, many different dimensions. But there's a lot of problems with string theory. String theory is background independent. In other words, in string theory, all the energy and all the stuff that happens and the vibrations of the strings all happen in this like emptiness, this void. They all just float around, affecting each other. But all the quantum gravity equations we've ever made that work, including those by a guy named Lee Smolin, loop quantum gravity. Have you ever heard of this? Did you know that 20 years ago, he and his homies wrote equations for how gravity can work on quantum scales? That's pretty amazing. Nobody had done that before. The reason we don't have a unified field theory is because we don't know how to connect gravity on these massive scales, general relativity, special relativity effects, down to the quantum mechanics happening at super small scales, right? If you can bridge those worlds, you have a unified field theory, right? But every unified field theory so far that's getting there that has equations for quantum gravity involve the space-time fabric itself being a lattice, being a structure, being made of geometries of energy connected together. And it's because of those geometries of energy, which might be tons and tons of wormholes connecting protons together, as Nassim Haramein might have said. I mean, what are the Planck length distances in the structure in the first place? We don't know, right? But something is there. Something's got to be able to let light move at the speed of light without friction. Something's got to still have the tangible energetic forces that stretch and move and bounce between objects. Something's got to be creating these reactions. And it's wormholes, it's strings, it's something on that scale. But whatever's happening there is a structure. And all we need to do is understand that structure and how to apply light to it in just the right way. And I think we can make a superluminal spacecraft. Here's how we do it. This is just for fun. But seriously, it could totally work, you guys. Okay? Power source. We use a zero-point energy scalar resonance capture. Okay? Or we could use something else too. But the idea is we use a resonance with the fabric of space-time, knowing its shape. We know the shape of it, right? So if we know the shape of it, we start learning how to access energy that's moving through it. We start to tap the chi of the wormholes, right? We start to tap the electromagnetism that's moving through space-time all the time, everywhere, and call it in, bring it in, and start putting it to work, right? Making it run our devices, making it charge our iPhones, right? Navigation. How do we get around? Okay, we power the ship. Awesome. Well, why not a mind link to the ship? Wouldn't that be cool? Because then what I would have is I'd be sitting there and I have a holographic display system up, and I would be able to see the stars around and see the planet, right, in 3D, and I could use the holographic display and zoom in to see closer to a star, use a system of 3D modeling like Celestia, which is a free open source software you can download online. You can travel through our galaxy in 3D. You can fly in on a planet, you can rotate around it, you can see if it has moons, which most of them don't yet because they haven't plugged it all in yet. But you can fly to the planet, you can turn around, and you can see what the constellations look like from that star. That's pretty dope. So I could sit there with my holographic display, zoom in on the Pleiades, rotate around Maya, and then I think to the ship, move avatar to this location, move ship to this location. I want to be right there. And the ship goes and jumps, and I'm floating over Maya. It refreshes, and now I have a live view of where I'm at. I turn around, there's Earth, my thing, zoom up over to Arcturus, right there. And if I want to go slowly, I can frame drag, so I can just basically think I'm moving closer to the planet, and I move closer, think and I'm flying around, think and I'm lowering down, and the more I get familiar with moving things around with my mind, the better I am as a pilot or navigator, right? So we can use other things like the location library. In other words, Celestia is a location library, but we need to have the harmonics of all those locations, right? So if I'm here and I want to get to Alpha Centauri, right? I need some information about what the geometry of space-time and the energy of that location looks like, right? So how do I do that? Well, where I'm at right now, Alpha Centauri is pretty far away. And in fact, when I look at Alpha Centauri, I might see it, and it's actually years and years and years in the past from me looking at it from where I'm at right now. My perspective on Alpha Centauri is a long time ago, right? Because it takes light a long time to travel to me from there, right? And over that time, let's say it's 100 light years. I'm not sure exactly how far Alpha Centauri is, but let's say 100 light years. And I use that 100 years ago perspective of Alpha Centauri. Well, what if Alpha Centauri blows up, right? What if it blew up 50 years ago? and I'm seeing it 100 years ago, right? That's kind of a problem, right? Because then if I warp over to Alpha Centauri, I'm in the middle of a giant erupting supernova, and that's a problem. But there are things that are a little bit more stable out there, and those things are called pulsars. Pulsars, light frequencies, pulsars' shape, their structure, their timing changes at a very, very specific rate that we can measure, and we can know exactly how fast it's going to be pulsing 1,000 years from now. And because we know that, we can use the resonance of that pulsar and other nearby pulsars to calculate an exact connection point between those pulses that is a spot anywhere in space-time. And even if it's 1,000 light years away, we're going to know exactly what the resonance of that spot is in 1,000 years. There's a gentleman who's done a bunch of research on that, and you should look it up, Pulsars as Galactic Network. And he believes that other civilizations actually set up pulsars all over the galaxy to use as navigation beacons so they could travel around really easily, right? Super cool. So we need to build a library of those things so that we know how to get all over the place and then access them. Life support. Well, we have our replicator, so we can have plenty of coffee and tea and crumpets and other lovely things while we're traveling. We need an internal field resonator to generate gravity and stabilize the field inside the ship so that I can walk around inside the ship, and then if we want to, we can turn it off and we can float around inside the ship and have the anti-gravity experience, right? But we need to be able to have gravity on, because with gravity on, our muscles stay strong, we can do a lot of cool stuff in the ship, and it's like normal. And when we want to turn gravity off, or you can go into a room and turn gravity off in that room, and you can enjoy the effects of the anti-gravity. So then we need to make a gravitational envelope around the craft, okay? This is where it gets fun. So to do this, we need a standing wave ring light system to basically create an envelope that's separating the internal space-time fabric from the external. In other words, as the folds and the waves of gravity move through, when it hits that spot in the ring around this object, it cuts off. It drops off. The effects of that curvature are no longer passing through that barrier, okay? That barrier is basically creating a very, very, very small ring of singularity, so to speak, around that object. A place where the space-time fabric goes into a state where it's entering infinite energy, infinite space, right? Now that sounds insane. You're going to surround yourself with a ring of wormholes? No, no, no. It's not the idea. Actually, you're using the existing singularity in the fabric of space-time. In other words, the existing holographic connectivity between each point in space-time that's already there, and you're aligning to it so that that 0 point in the fabric of space is wrapped around your object, okay? That's how you have to make it happen. And to do that, you need to resonate with the geometry of space-time at the Planck scale. So we need to know the geometry of space-time, which I invite you to check out Nassim Haramein's work on that and my own work on that. And then we need to start to learn to resonate it to create an envelope around an object, right? And then we need a superluminal drive, right? Superluminal drive, what that means, faster than light drive. Now to do that, it's the way I described before. You need a library of nearby stars and locations and a field resonator around that envelope, like another ring that's just outside of that, that tells the surrounding space-time fabric, I'm in red star zone, not in blue star zone anymore. So you create the envelope that's like separating space-time, and then you tell the surrounding space, but actually I'm over here. And because of that envelope that's negating gravity around the object, there's no acceleration, there's no speed up, there's no pushing through it. It just, it's as if it's already there. Just slides through the fabric like a bubble. Imagine you take the layers of the fabric and you just open them up, and then you're just moving through. and you can go through it as fast as you want, at any speed. You can take 5 minutes to get there, you can take 5 hours to get there, or you can get there instantaneously. Jump to that location instantly. It's up to you. It's kind of like time control. Mr. Mallet would be very, very proud. He'd be super excited about this. So, piloting skills, to do that, all you need is a good practical skill set in mental projection, or astral projection, sometimes it's called, but basically projecting your consciousness, thinking you're over there while you're standing here. I imagine myself standing at the side of the room, looking at myself speaking. There I am speaking, there's my back, I'm talking, my hands gesturing, I'm looking at you guys, looking at me, looking at the screen. You know, I jump up there, I see the guys running the tech boards, right? And I imagine it with my mind, but that's all I need to be able to do really clearly to be able to move a ship to another location. See the new location in my mind and move it there. Or imagine I'm flying over a landscape and the ship will follow, right? Move like an avatar in 3D space, but it's moving in actual 3D space, right? So, and you also need to know a little bit about astronomy so you don't pilot your ship straight into, you know, a supernova or a wormhole or something like that. It could be a problem, right? So basically that's how we do it, right? Now I know that all sounds really freaking complex, but think about a car. How does your car work? If you try to stand there and describe to me how your car works, you think this is complex? No. This is actually really simple. To get your car to work, you've got an igniter spark that hits this thing and starts a combustion process, and then there's all of these cables that pop different sparks at different times that are routed by a distributor. Then the gas goes through a fuel pump and runs into the thing so it explodes just right. And it explodes not too much so that it doesn't blow up your engine. And then basically that thing goes through and it pushes through a drivetrain and it spins the drivetrain and you clutch the drivetrain into a gear position, which then puts the force of that explosion into the drivetrain and moves the car, right? And planes, look at a 747. How the heck does that thing lift off the ground? Talk about a complex system that works. And the only reason it works and the way it works is that it simply works off of the principles of the physics that we understand. So if we change the principles of the physics, in other words, if we break through some of those breakthroughs that we're talking about, with understanding the fabric of space-time, this stuff is easy. We're already most of the way there. We already have a lot of these pieces about to happen. It's just a matter of applying the lessons, applying the new awareness and the new technologies that we're coming out with right now in an integrative way to try to do something different. Okay? Sounds cool, right? So is this the near future? Is this where we're going? Starfleet Academy? You get to go to schools, wherever, learn how to pilot starships, learn how to fly across the universe in those starships, right? Art as a primary value system. So instead of going to work at Mickey D's or, you know, the local shopping mall, right? Well, maybe I still do that. But instead of going to work at Mickey D's, maybe instead, because we have replicators and we're no longer using gold standard or monetary value systems the same way, maybe then I actually do the thing I've always wanted to do, which is practice music or play music and share that music with the world, right? Maybe I get out there and I start teaching people about something that's my passion, sharing stories about the things that I love, you know? Things I've lost in my life, the lessons that I've learned from that, right? And maybe I start revealing myself more to people. Maybe I start expressing my deeper self, and maybe some of the issues, the tension, the frustration, the problems that exist all over the planet because people aren't doing what they want to do and they're still fighting for survival, maybe those issues start to change, right? And maybe we stop trying to attack other countries or create wars for resources, right? Maybe we begin to look at the planet as a major, major gift because it creates life, because it creates consciousness, because it gives us all of these amazing gifts, and maybe we start giving back to the earth in huge ways. Maybe we start making sovereign communities, right? Communities that are totally independent and able to make their own choices about life and stay connected with everywhere else through our amazing instantaneous communication system, right? And we start making sure that every human being has everything they need. Everything they need to live, to survive, and to thrive. We start healing, right? We start healing things and coming into our harmony with the earth, start balancing things out, start creating with the patterns of nature, repairing the damages that we've caused to the biosphere. And we start stepping up in how we use these gifts that we've been given, these gifts to create. And everyone starts stepping into position, into the roles and the path that empower them the most and that let them give their greatest gifts to the collective. It's a beautiful dream. Gene Roddenberry had that dream when he talked about Starfleet. And in the new Star Trek movie, you kind of get a little different perspective, like it's a military operation. And yeah, it is very much that. It was very much that in his vision because it took a lot of responsibility to run a starship, right? But it was only that piece. Everything else is up to you. What do you want to do? Do you want to be a doctor? Do you want to be a scientist? Do you want to be a healer? Do you want to do anything? If you want to do anything, there is education available for you to do that. All you have to do is want to give. All you have to do is want to get out of the bar and get out of your house where you sit and you have all your things taken care of and all of life is just done for you, and get out into the world and actually offer what those gifts are that you have to give to everybody else. That's what it's all about. That's where everything changes. And really, that's something we should be doing right now. That's something we all should be shifting towards. Whatever it is you do, whatever your job is, however valuable you think that is, if it is not the thing that is the most core passion for you in your life, then it has no value. The money doesn't mean anything. The value is nothing unless it's expressing your art. Right? That's how we change things. That's how we heal things. And remember, there may be other civilizations out there that have been doing this dance and figured this out and got through this progression point of developing starships, developing new energy systems, exploring new worlds and new civilizations. And they may have done it a long, long time ago. And we always, always have a lot to learn from those civilizations. A lot to learn from what's already happened out there, right? There are a lot of beautiful, beautiful gifts that we're just now discovering on this planet that may have been left here by other civilizations. We are just beginning to explore and discover what there is out there, who we are relative to other beings. And imagine what happens to our culture, to our ideas about things, to our conceptions of what's possible when we not only have all the brilliance of humanity to reflect upon, but the brilliance of thousands and thousands of other incredible species spread throughout the stars. Thank you so much for being here. Awesome. And I'm Adam Apollo. You can check out my website, adamapollo.info. And I have some of the writings of this, and I'm going to make this